Lesson 7, similar objects. So when we do this, we're going to make sure we go scale over actual. And when you're checking for similar objects, you're going to simplify and then compare. So for example 1, we have a large frying pan and a small frying pan. So for the small frying pan, we have a diameter of 20 centimeters. We have a depth of 4 centimeters, and we have a handle that is 16 centimeters. And for the large, we have the diameter is 30 centimeters, the depth is 6 centimeters, and the handle is 24 centimeters. So we know all the sizes, so we're going to find the ratio and we're going to compare between the three. So first we're going to do the diameter. So the scale will be the smaller one, so 20 over 30. Now we're going to simplify. So to simplify using the calculator, you type in 20 ABC 30, and it should come up with the answer 2R3, which is the same as 2 over 3. If you can't figure out how to simplify the fraction, you can also find it as a decimal. So 2 divided by 3 equals, and it's 0.6 repeating. So you can either compare it as a fraction or you can compare it as a decimal, whatever your calculator does best for you. So now we're going to do the depth. So we have 4 over 6. If you type in 4 ABC 6, you should get 2R3, so 2 over 3. Or if you type in 4 divided by 6, you'll get 0.6 repeating. And for our last, we have the handle, which is 16 over 24. If you type in 16 ABC 24, you get 2 over 3, or you could do 16 divided by 24, which is also 0.6 repeating. So when you compare, which is your last step, you're going to look at all the simplified either fractions or decimals, and if they're all in the same, that means they are in proportion. So I'll write that down. They are in proportion, and remember that word, it's very important. Therefore, remember 3 little dots in a triangle is therefore, they are similar. So they're similar objects because their lengths, their sides, are in proportion. Okay, solving for actual sizes. So we're going to use scale factors. So first we have a scale model of a tractor that has a height of 12.7, a width of 19.1, and a depth of 9.5. So that's all you really need for a diagram. If you really want to draw like some kind of tractor, it's like 3-dimensional, you're totally fine to do that. I mean, I'm not a huge artist or anything, but this is pretty good tractor that I'm drawing. So, I mean, if you want to unleash your inner creative side, go for it. Here's my tractor. It's really good. And so the height is 12.7. The width is 19.1, and the depth is 9.5. And it doesn't say this on the question, but just add in that the scale is 1 over 16. So just add that in. I forgot to type it in for some reason. So what we're going to do is we're going to use the scale factor to determine the actual lengths of this. So first we're going to do the height. So 1 over 16 is our scale, and we know that the scale drawing has a height of 12.7 we want to find the new height. So 12.7 times 16 divided by 1 equals x, and if you type that into your calculator, you should get 203.2 centimeters. So that's the height of the actual tractor. Now we're going to do the depth. So 1 over 16 is our scale. We know that the depth is 9.5, and we're looking for the new actual size. So 9.5 times 16, divide up, so divide by 1, equals x, and you should get 152.0 centimeters for x. So that is our actual height, or depth. And the last is we want to find the width, so we have 1 over 16 is equal to 19.1 over x, cross multiply, so 19.1 times 16 divided by 1 equals x, and you should get 305.6 centimeters. So there are all the new lengths. So the dimensions of the tractor is actual size is these three lengths, 203.2 by 152 by 305.6.